Hey, you're listening to About Time, a podcast produced by Timely, the world's first AI-powered time tracking app. For an automatic record of all of your time, head to timelyapp.com. In the last episode, we introduced the idea of subjective time, our personal sense and experience of it, exploring how memories, emotions, and cognitive processes influence how quickly or slowly we feel time passing. But our experience of time isn't just lived inside the brain. We can't fully grasp the time that runs within us without recognizing the role played by our bodies. In the next 20 minutes, we'll trace the silent clockwork that governs our bodies and secretly shapes our consciousness. I'm Emily, and this is the Physiology of Time. The time that exists inside us is silent, remote, and invisible. But we feel it everywhere around us and experience it most immediately in the very vessel that takes us through life, our body. If time is nothing but change, then the body is our enduring personal benchmark for tracing it. We follow it through a continual series of change, from growth through to aging. Modern science has even given us cues to help us anticipate different biological milestones. We know when puberty is likely to arrive, when our metabolic rate starts to dip, and when our ability to reproduce will stop. We even know when our natural life is likely to end. And as much as we like to think of our brain as the unshakable foundation of our experience, we need to recognise that it is also a biological creature. It completes full development when we are about 24, levelling off thereafter and entering full decline from about the age of 45 onwards. The brain tissue that stores our memories, the chapters of our own autobiographical time, undergoes constant change. Our body will continue to give time away, even if our mind does not want to buy into the idea. Just as Einstein showed that every reference body in space has its own particular time, we can consider our bodies as our reference point throughout life. And ultimately, they are full of time. Consider what you're feeling right now. Maybe you're sitting down at rest, or maybe you're up and about. Do you feel tired, alert, or calmly in between? What's the temperature like? Maybe you feel a slight pang of hunger, or maybe you're exercising, and all you can focus on is the thrashing of warm blood around your body, the throb of your heart inside your chest. Wherever you are, whatever you're doing, a whole network of clockwork mechanisms are at work inside you, regulating your breathing, blood pressure, pulse, hormone release, digestion, cell division, alertness, metabolism, and temperature, to name just a few. Each has an individual cycle or rhythm, which often follows a peculiar periodicity, working almost like clockwork. These biological clocks are found in virtually everything that lives. They are regularly repeated functions and behaviours that keep us alive and pace the rate at which we age. Some operate on a yearly cycle, like the germination, flowering, and dormancy of plants. And others follow a lunar month, like the menstrual cycle. But the rhythms that occur on a circadian or daily 24-hour cycle have perhaps captured our imaginations most. While it's easy to assume that this has something to do with our external environment, like the appearance or absence of light, circadian rhythms actually appear to be built into our biology. They may work in tandem with the day-night cycle, but they are not completely controlled by it. The study of biological rhythms, known as chronobiology, first showed this back in 1729. French scientist Jean-Jacques Dortu de Méran showed that a heliotrope plant would continue to unfold its leaves at set times, even when placed in darkness. And much later, in 1929, Carl von Frisch showed that honeybees trained to visit a nectar feeding station at set times would continue to do so even when an external clue like light was removed. So our biological clocks appear to be internal. Time is encoded in the very cells of our being. We now know there are two different ways these rhythms are generated. One is endogenous, generated within an organism. It is a self-sustaining mechanism that arises through our internal metabolic processes and controls inherent periodic systems like brainwaves and heartbeats. They are determined by the time it takes to complete a specific sequence of actions, like the contraction and relaxation of the heart. The other is exogenous, cycles that are imposed upon our biological clocks from our outside environment. So while our biological clocks seem to be innate, inborn instead of learned, they can be influenced by our environment. External clues like light, temperature, and redox cycles can all adjust them. Experiments have shown that when you remove an animal from environmental time clues, they will keep their daily rhythms for a time, but will eventually display free running time. While they may still eat and sleep on a regular schedule, they will increasingly become out of phase with a local time. Modern agriculture is a testament to the influence of external cues on internal rhythms. We can make plants flower and bear fruit out of season in winter just by subjecting them to artificial light and temperature control. We ourselves are able to change our sleep-wake cycles by timed exposure to light or by going to bed a certain number of hours later every day. So within a few days, we can fully reset our own internal clocks to a new environment. And the time we take to adjust to a new rhythm varies depending on our individual makeup. Sleep cycles are particularly interesting for a lot of reasons. They are our main master circadian rhythm, but they are notoriously inconsistent and flexible. Infants don't tend to establish a sleep cycle until about 6 weeks old, and it takes a further 16 for it to fully set in, often being influenced by cues from their parents' schedule. But even as adults, our sleep-wake cycle is constantly changing. Busy work and social schedules, stress, travel, and caffeine from our coffee all fatigue and disorient us, so our normal sleep-wake cycle is in constant flux. Bizarrely, we also all have a preferred timing for sleep and activity, being socially categorized as either a late or early riser. These preferences are determined by genetic variations in our clock genes, as well as environmental influences, and the whole cycle has a lot to do with our core body temperature. For morning people, your temperature begins to rise early, peaking at around 4 p.m. and then falling. For night owls, this temperature peak happens later. Weirdly, as we age, the separation between the two decreases, as our biological clocks shift more towards the morning. In stark contrast, teenagers' biological rhythms are naturally shifted later than adults. A recent study from the University of Oxford showed that cognitive performance of teenagers improved by 10% between mid-morning and mid-afternoon, while that of adults deteriorated by 7% over the same period. Teenagers' later chronotype meant they experienced a later natural peak in alertness and reasoning. All this fluctuation in our natural sleep-waking cycles seems rather inconvenient. And indeed, through the world we can see our biological clocks are often at odds with our social desire to organise and control time. Social schedules like school and work can considerably interfere with our own individual sleep preferences, so that people with later chronotypes build up substantial sleep deficits by the end of the week. It's a phenomenon scientists like to call social jet lag, the gap created between our biological clocks and the external clocks that rule our lives. While offering later school starts and more flexible work schedules is a start, minimizing the effects of social jet lag may require rethinking the very social apparatus we use to organize time, or more specifically, the application of one in particular: daylight saving. The practice of winding clocks back an hour each autumn and forward again each spring was first introduced in 1916 and is now followed by about a quarter of the world's population. While the intention is innocent enough to give us more natural light in the morning as the seasons shift, the consequences can be disastrous for our biological clocks. The movement to summertime and its consequent sleep deprivation has been linked to an increase in accidental deaths and injuries, notably road traffic accidents. And clock changes have been tied to everything from elevated risk of heart attacks and strokes to an increase in suicide attempts and psychiatric admissions. No matter how much we want to control time socially, we cannot deny our highly sensitive and individual biological time. But what about our conscious experience of time? In the last episode, we touched upon the idea that our cognitive function and emotional state can impact the perceived passage of time, making it either speed up or slow down. But can our body play a role in this too? Neuropsychologist Marc Wittmann seems to think so.
The perception of the bodily signals is really essential for our feeling of passage of time. And this is clearly seen in all these states when you're feeling hungry, feeling thirsty, when you're feeling pain.
In comparison to neural studies of the brain, research into the body's impact on our subjective experience of time is rather lacking. But we do know that physiological and biochemical changes can warp our perception of duration. Take illness, for example. An increase in our vital functions will lead us to overestimate time, and a decrease will lead to an underestimation. This was first discovered by Dr. Hudson Hoagland while nursing his feverish wife, as Marc explains.
Experiments have been done with people who have fever, that they also totally overestimate time. So it actually happened to a medical doctor's wife had fever, and he just went quickly to the pharmacy to get some medicine. And he came back, and the wife complained, "Why had you been so away so long?" He had just been away 10 minutes, but she totally overestimated it. So, and they needed, as a real scientist, a few time perception experiments with his wife while she had the fever, and he really found out that she overestimated all the intervals, the duration he sort of indicated to her, and so the conclusion is something like your bodily feelings define subjective time.
So the higher our body temperature, the longer a minute seems to last. And subsequent experiments have also confirmed that a lower one leads to an underestimation of time. Pain has a similar effect, stretching the present so that it is lived slower than normal. But perhaps even more interestingly, our inner clocks also govern symptoms of illness, the progress of disease, and our rate of recovery. French biologist Pierre Le discovered this in his experiments on wound healing, pointing to the fact that tissue repair was 5 times slower at age 60 than at age 10. Physiologically, time is not the same for a child as it is for an adult. Then there are environmental factors which induce changes in our physiology. Experiments show that people's sense of duration becomes strongly impaired over several days when they are deprived of sensory stimuli, like sound, touch, and visual clues. In most cases, reporting time to pass painfully slowly. Seasonal affective disorder, which in its extremist form affects 11 million people worldwide, provides further proof. While an absence of light appears to affect the release of a mood-regulating chemical called serotonin, it is our genetic makeup that determines our susceptibility to the disorder. Of course, what we actually take into our body can also affect how we experience time. LSD, mescaline, and cannabis can all produce states of altered consciousness, making time race for some, stand still, or even reverse for others. Caffeine, cocaine, and amphetamines actually speed up some of our bodily activities to make time intervals seem longer. And depressants like alcohol and tranquilizers have the opposite effect, slowing things down and making time seem shorter, causing users to underestimate time's passage. So depending on what drug you take, you have a very different experience of yourself and of time. What we feel and how it makes us respond to the world around us is largely formed by information originating within our bodies. So we cannot speak of mood processes as timekeepers without also acknowledging the impact of physiological ones. But some scientists have gone further than this, suggesting that the influence of how our body feels helps construct our material self, on which our whole conscious experience of time is based.
Self-consciousness is basically very much related to the experience of time. So the more you sense yourself, the more you sense time. And so subjective time and this phenomenal self is very much linked together.
In the West, the self is the enduring, unitary entity which we use to interpret our lived experience. But the self is only possible as an entity across time. Since bodily signals are a permanent and ongoing feature of our lived experience, they could function as an inner measure of duration, where we match external temporal intervals against the duration of physiological changes and the emotions they evoke. Take this example of feeling bored or having low energy.
Sunday afternoon, you're sitting there on your sofa and you just don't know what you want to do. You're having this feeling of boredom. And what does it mean? You're feeling yourself very strongly, and time stretches totally. And this could also be exaggerated in states of depression, for example. This is even more strongly where people really absolutely feel stuck in time. Time is not moving. There is no future.
So in many ways, our phenomenal self, or the sum of bodily signals we've received throughout our lives, creates our sense of duration, where time is the measure of a self that is constantly becoming. So what has the physiology of time told us? That our bodies are full of inborn clocks. They respond to external cues from the environment, but exist outside of them. Unconsciously, it seems, we can keep our own time. But our bodily time is also flexible. The Earth's particular rotation has impressed a 24-hour regularity onto the genes of most living creatures. But simply travelling to another time zone can change or reset our internal clocks. Time zones themselves and the schedules we adopt within them often lead to a disconnect between social designs for time and actual biologically experienced time. Despite our best efforts, we are biological creatures. We observe the regularity of what appears to be time's passage in the aging of our bodies. We feel time and use physiological signals to situate ourselves within it. Changes in our bodily states and sensations may function as timekeepers, providing an internal reference for subjective time when judging duration. We already know that changes in our temperature, the experience of pain, or consuming different substances can cause our experience of time to contract and expand. But ultimately, we know that the time of our lives is a unique expression of our own self. We each have our own time system that is fed by information originating within our bodies. Nobody's time is quite the same. It completely depends on how we each feel and perceive it. So the very force that gives cadence and structure to our life is completely individual. We all make our own time. You've been listening to About Time, a podcast produced by Timely, the world's first AI-powered time tracking app. Join me next time in our last episode, where I'll be exploring the construction of time, taking a closer look at the technologies we have created to try and unify and standardize time. From calendars to atomic clocks, timetables to time zones, we'll chart the attempts of successive civilizations to capture, control, and master time. In case you missed any of our previous episodes, like the language or psychology of time, you can catch them on our About Time page at timelyapp.com/abouttime. If you like what you heard, leave us a review, share it with someone else, or download the episode to relive it all again. Thanks for listening, and thanks for your time.